Okay, welcome to the second to last teaching of the year. Woo. So just teaching today and Tuesday, and then I'm done teaching. Yay. I'm working on the final exam review packet note sheet thing. Um, okay, team has that sort of stuff. So okay, so today I'm going to teach you how to describe a data set. Data distribution means like a set of numbers. We've been working with sets of numbers since the start of this unit. So we've been describing them already by finding mean and median and mode and IQ. Do you guys know what the mode is? Okay, but I'm going to talk about the mode again in a second. And min and max and making a box plot and doing a histogram. Those are all data distribution. And now we're going to do the part where we describe it. There are four things that you need to state when you describe a data distribution or data set of numbers. Distribution just means set of numbers. And I gave you a little acronym up there to help you remember. It's called SOCS with no K. SOCS. Shape, outliers, center, spread. So we're going to talk about all four of those things in our lesson today. And these are not all of the shapes, but these are the most common ones. Notice I drew the box plot, and I'm hoping you drew the box plot above those three, because I want you to see how the tail would look on the skewed ones. So this was that like sort of Smallville feel where the numbers were all kind of similar to each other, and the box plot's kind of evenly spaced. On this left skew, the tail is pulled to the left, and on the right skew, the tail is pulled to the right. So what I want you to think about is like when you have something on a computer and you drag it, feel like this is dragged to the left and this is dragged to the right. Helps you remember which is which. Okay, and then I've got some different ones down here. Uniform, it's just like, I like to think of it of like when somebody mows the grass, you know, they're not all perfectly exactly the same, but they're kind of like really close to each other, hopefully. Bimodal. So when I come back to this word mode means the most. So this means two peaks. Bi is two peaks. And then this one is multimodal, meaning it has three peaks. These are weird ones. You don't come into contact with those super often in stats. The top three are the most common. That's why we do the box plots. For those, you could see how it would affect this again. Do you have any questions about this so far? Last year, I made the kids try to draw those, and I was like, you know what? We're going to do arts and crafts instead today. Yeah, that's right. Yes, yeah, it can be anything above two. There could be infinite modes. That'd be a wacky graph. Okay. All right. Now, if you guys could put outliers, center, and spread down the left side of your paper, and then when it starts at center, draw a line down the middle, and I'll explain why in a second. We are going to draw a picture for outliers, though, so just so you know. Mentally prepare, there's going to be some art required here in a moment. All the way down. Just trust me. Okay, so first thing we're going to do is define outliers. Outliers are any data value that is far from the rest of the data. Outliers, any data value that's far from the rest of the data. Okay, now we're gonna do some art. Here we go. It's gonna be great. Maybe. Okay, does it have to be perfect? No. Let me finish this real quick, then I'll give you time. The definition of outliers isn't that weird. I mean, anything kind of far off. But I want to mention a couple of things. Gee, one thing. You actually, in this class, you're not going to know whether or not something's an outlier. There's an actual procedure to tell whether or not something's an outlier. We don't learn that in math one. We learn it in basic stat. You don't need to know. We can just estimate whether or not we think something's an outlier. Okay, second. Yes, sir.
Oh, I saw this in that public yesterday. That's the thing you
About,
the outliers.
oh, like how to tell?
Yeah,
Did it have you to figure out how to tell?
yeah. I'm gonna speak here. But if I had to switch it up.
Um, the other thing I want to tell you is that sometimes if you see a box plot, it's gonna have little X's for the outliers. Sometimes it doesn't, it just has a long tail. We're gonna do the long tail in this class. But I wanted to put the X's in, because I think you ever saw that in real life. Can you guys try not to mess with the office supplies? That's why I don't put them out anymore. Okay, so I want to show you though on my calculator here. This is a box plot with outliers as little dots, and then this guy is the box plot with the long tail. So I want you to know there's two ways to do that, but we're going to do it with the long tail. Just so you know, we don't need to worry about whether or not something's an outlier for the moment. We're just going to estimate. Okay. Now, center. We talked about this yesterday in yesterday's lesson. So we're going to ask a question in center. We're going to say, any skew or outliers? And underline the word or because it's either one, any skew or outliers. The center is the median. Do you guys remember we talked about that yesterday? You want to use the median if there's outliers?
We've talked about how to find the median lots of times. And the median has a symbol, it's capital N. If there's no skew or outliers, meaning it's like a data set where all the numbers are kind of close to each other. It looks kind of symmetric shaped. Then we want to use the mean. Add all the numbers and divide by however many there are. The mean has a symbol too. This is called X bar. Just think of it X with a bar over top. You can write average or mean. I'm just telling you if in case you see the symbol, what it stands for. By the way, if you were wondering what this poster means all year over here, now you know it's X bar standing in front of class and it says, I hear she is really mean. Because that's the symbol for me. Yeah. Yeah. So the whole point was whether or not there were fewer outliers, which one to choose. You can fix it however you want. Okay, last thing for this spread. Spread means how spread out the numbers are. And if you're using the median, so this is very important, you need to use the spread that's called IQR. Have you guys heard of IQR before? It's interquartile range. And IQR is very easy to find. It's quartile 3 minus quartile 1. No big deal. Median and IQR are best friends. Do you guys know why median and do you have a common sense explanation of why median and IQR would be best friends? Okay, let me ask you this. What's the first step in finding the quartiles? Yeah, finding the median. You need to find the median in order to find the quartiles. So it has to go like in this order. Now, the mean. Do you need the mean to find the quartiles? No, there's a different spread when there's no skew or outliers, and it's called standard deviation. And this is its symbol, S with a subscript of X. Standard deviation is not nearly as easy to calculate as IQR. So we're going to write ourselves a little procedure on how to find standard deviation first. List the numbers in a column. What? What? Oh, nope, 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 nope. Sorry. I don't know what I thought you said. My bad. Okay. 2. Subtract the mean from each number. Okay. And there you go. So right there is your clue of why mean and standard deviation go together, because you need the mean in order to find standard deviation. Step 3, square all of the numbers. One of the things you're going to notice in stats is that they don't like negatives. Yeah, with a very small data set. We're going to practice it after this. Add them all together. Divide by however many there are minus 1. And then square root. Okay, now can you guys grab your packet when you have this situated? Take your time, take your time. Yeah, grab your packet after this. When you got this all set, grab your packet and find the 10.1.3b resource page, this one. Okay, and I wouldn't put your notebook away if you can. We're still gonna use it for to answer these questions. Okay. All right, so first I'm gonna grab my note and I'm gonna grab this. Which shape is this right here? Skew right. Notice how the tail is going to the right. Most of the data is on the left and it's being pulled this way. Okay. Skew right. Okay, now remember, this is something you guys need to remember about stats. Yes, Michael? Yeah, of course. Um, they're not, every graph's not gonna look exactly perfect. Unfortunately, they're all gonna be a little different. Okay, outliers. So we look for these little dots next to the box plot. It looks like these four are outliers. Can you guys tell those are the four highest numbers in the data set? Okay, so we're gonna write outliers are 220. Wait, that's 269. That's 220. That's 218. That's 154. It's all of these. So I'm gonna make a little note. 154, 210, 220, 269. Can you guys all tell where I got those numbers from? Right here in the list. And then I just looked at the scale down here to figure out. Oh, what are you talking about, Jalen? I don't know what you're talking about. It totally was 218 the whole time. Nothing weird happening. Okay, but does it make sense where I got those values from? The table? Okay. Okay, so we're just gonna go over to the spot that says outliers and we're gonna write 154, 218, 220, 269. Okay, now center. This is the hardest part. So tune me back in. If you're just tuning out, tune back in right now. Okay, so center. I have to ask myself the question, is there any skew or outliers in this problem? Yes. This problem has both, actually. That means I need to work on this side of my notes. Yeah, you have to do the median and IQR. Okay, so since this is 40 holes of golf, this is somebody's penny numbers. We need to find the middle, which would be right in between these two. Agreed? Okay, so the median would be right between them, which would be 48. Okay, so you say median. Okay, now which measure of spread goes with the median? Okay, let me ask you again. Which measure of spread goes with the median? IQR. Okay, so because there's skewer outliers, I'm on this side of the notes. IQR. Okay, so we need to find the quartiles. Okay, so let's see. Quartile one would be between these two. Which is 33.5. Does that make sense to you guys? 33, what's right in between 33 and 34? Okay, so Excellent question. All right, so did the median make sense? Okay, so what you do when you're finding the quartiles is you just say, okay, I'm only gonna look at the bottom half of the numbers and everything below the median. How many numbers are there? 20. So I have to break it up into two groups of 10 and 10. And it would be in between the 10th and 11th. Okay, so if that's the case for quartile 1, then where would quartile 3 be? Yeah, in between these two. Which would be 79. Michael, you want this part? Okay. Yeah. Yeah. Michael, tell me when you want me to move it down. Oh, you mean after this? No, however, well, yes. So Jalen has actually found my final point of the day, and that is your center and spread should always have units. This is centimeters. So these should be centimeters. Okay, now this is kind of awkward, but can you find the warm-ups? Yeah. Yeah. I'll give you my packet as soon as I'm done teaching. Okay. We're gonna do 2 warm-ups today. We're gonna do 7 and 11. Okay, and number 7's gonna take us a little bit of time. So I'm gonna warn you that we need to buckle in for number 7. This is the first time I'm going to teach you how to find the sample standard deviation. So we wrote down the steps in our notes, but we need to actually do it now. So I'm gonna try to show both of these in the same screen. Okay, first thing I need to do is find the mean though. So if you guys could on your calculator, add up all the numbers and divide by something. Mm. 11? No, I don't know. Hold on, I didn't count them yet. Yep, you're right. You don't have to. Okay, so we found the mean. Mean is 6. I don't know how to show this without it being on YouTube. Okay. Step 1, list the numbers in a column. They do not need to be least to greatest. 4, 7, 4, 6, 7, 6, 6, 7, 5, 7, 7. Okay. This is going to be tedious, just so you know. First, list them in a column. Number 2, subtract the mean. I really like how my list got smaller as I got further down in the thing. Okay, step 3, square them. Notice how they all came out positive. Time to wake up, 10:15. I wish I woke myself up in not in a nice way. My alarm goes. Mrs. Talbot, yeah, there's 7,000 different things to choose from. I know. Okay, add them all together. All right, so 4 plus 1 plus 4 plus 1 plus 1 plus 1 plus 1 plus 1. 14? Okay. Okay. Divide by however many there are minus what? There's 11, so you're going to go divided by 11 minus 1. So 14 divided by 10 is 1.4. Step 6. So the reason you don't want the whole explanation, I can give it to you if you'd like it. But the reason is because if this is from a sample, you have to be more conservative. So you can't divide by however many there are. You have to divide by however many there are minus 1. It's because there's 11 numbers. But this is always minus 1. So however many numbers there are minus 1. Okay, and then last step is square root. Okay. Nope, we're doing number 11. Okay, let me actually explain one sentence though about who actually just calculated. Because did a lot of work there. There's a lot of arithmetic that happens. What on earth does the 1.18 mean anyway? Okay, what it means is the games per World Series are typically 1.18 away from 6. So it's saying that data set, that's how close they are together. They're typically 1.18 from 6. So the average distance from 6 is 1.18,
Love it to be on that.
because I asked. But don't take stats if you hate it. Okay. All right, last problem of the day, down to number 11. Also, I was just gonna say, let's say you were actually gonna go to the World Series, right? And you were gonna buy tickets and you wanted to know how many games you could expect to see. This would help you decide if you were making a good financial decision or not, because World Series tickets are expensive. I know. I know.
Crazy.
Okay, last problem of the day and last problem of the week. Here we go. So I rewrote the problem with equals. And what I want to remind you is you need to get the absolute value alone before you split it into two pieces. You can't split it into two pieces right now. So a -3 first. Then I divide both sides by -8. And now I split it into two pieces. And this is going to be a general theme. As you guys get higher in math, you're going to have to isolate whatever it is you want to work with. Okay, I put closed dots in. All right, what value do you think is best to test? 0, right? Excellent choice. I got true. Anyone else get true? Okay, good. Okay, so when it's true, that means the line goes between the dots. And my final answer is -10 is less than or equal to A is less than or equal to 6. And remember, arrows always point left when you have the line going between the dots. Always left. Always left.